Hello and welcome to AGN 3613. In the last session, we addressed the compound amount factor and the sinking fund factor. In this session, we are going to address the capital recovery factor. As you can see here, the same formula, we are using the same formula again and again, just doing some basic algebra on substituting the terms, some of the terms, to get the values or the variables that we need from these equations. In the equation that we took for the sinking fund factor, we know that the annuity is equal to the future value multiplied by the sinking factor. But we know that from the basic equation that we had before, that the future value is equal to the principal multiplied by 1 plus I to the power n. So actually I can take f from here, from that equation, and replace it with the value of p multiplied by 1 plus I to the power n. And let me use the pen here. So actually I'm replacing f here with its value, and its value here is the p multiplied by 1 plus I to the power n. And that's what I got here. So a is equal now to p multiplied by 1 plus I to the power n multiplied by the sinking fund factor. So this was the sinking fund factor. Now I added another factor to it. If we do that, then I can get the 1 plus I to the power n inside. I can get it to, I can distribute the value, this value, and multiply it inside. So we multiply by I up here, and then it will be, the equation will be A is equal to P, the principal, multiplied by I, which is multiplied by 1 plus I to the power n, divided by 1 plus I to the power n minus 1. Now all this value is called the capital recovery value, value or factor. So this is my new factor. And again, I got this from the basic equation that we started with last time with the annuity. So always we start with the basic equation, and then we start extracting the other variables that I need from that equation. And that's what we did with the compound amount factor, with the sinking fund factor, and with the capital recovery factor. This factor can be written in a different way as we used to. We can just write it as A given P with interest I and a number of periods n. And we write it like this to get it from the table in the back of the book. Let's take an example about that. We would like to pay an education loan that we got right now or today with the principal of $21,061 and 82 cents over the 5 years, and with interest rate equal to 6%. What will be the annuity to pay back this amount? If we calculated the annuity, we know that A is equal to P multiplied by the factor, capital recovery factor. So we multiply 21,061 and 82 cents with the recovery factor, the capital recovery factor, and we will get 5,000. To calculate or to get the solution for this equation, we can either do it through this equation, through the main formula. We can get the value of the factor from the back of the book, or we can use Excel sheet. All of them should give you the same results, whether you use the method of the formula, mathematical solution, the factor, finding the factor from the back of the book, or having it in Excel sheet, calculated automatically with Excel sheet, you should have the same value, which is 5,000. So you have to pay it 5,000 over 5 years. Now, what if they give you a deferred loan payment plan, which is, we're going to give you a break. You don't have to pay the first year. You have to start, or you can start the second year. What do we do in this case? And we call this as grace period. In this case, we have to move the principal value 1 year ahead. Since I'm not using the time now, which is the time at t0, t equal to 0, then let's move that value, the p, to the first year, the end of the first year. And to do that, we have to find the future value, which is, in this case, we're going to call it the new p, the new principal value, will equal to the old principal value multiplied by the compound amount factor over 1 year. So n is equal to 1 year, and we have interest of 6% over this year. We can find the new p prime or p dash value, and that will be my new principal. After I do that, now I use the same formula to calculate the new annuity over 6%, and with 5 years now it will take me all the way up to year number 6. So now this is 1, this is 2, this is 3, 4, 5, and those are the 5 different payments that I will use to pay back my principal, my new principal. Using the formula, this is the new p value that I will use now in my capital recovery factor, and I will calculate again. I will use the recovery value for that factor. I will use the value for that factor, and I will multiply it by the new p, and I will get 5,300 per year. So if you would like to defer it 1 year ahead, instead of paying the first year by the end of the first year to pay by the end of the second year, it can be done, but that will add $300 on your annuity payment for the next 5 years. So it will be up to the institution or up to you to take the decision that I would like to defer it another year until, maybe I settle down, or I will have a stable job to start paying back. But by doing that, then you have to pay more. Instead of 5,000, you are paying a difference of 5,300, which is a $300 difference just to defer it for 1 year. The same way that I got the annuity, I can get the present value. So if I have the annual payment or the period, the equal period payments, then I can also find the present value as we did before. The same formula can be used for this calculation. So the formula that you can use to find the annuity, it can be used also to find the present value, and we call it the present worth of annuity series. And we use either the formula P is equal to A multiplied by 1 plus I to the power n minus 1 divided by I multiplied by 1 plus I to the power n, or we can use the factor, which is in this case written as P given A with the interest rate I and a number of periods n. For example, if we have a Powerball lottery, and they would like to give you, instead of giving you lump sum for that amount, they would like to give you annuity of 7.92 million over 25 years with an interest rate 8%. What would be the principal value at the beginning if this value was given to you. Using the equation, we have the annuity, which is 7.92, multiplied by the factor. Then the principal today will be 84.54 million dollar, and this will be the value that will be given to you now if it was given on annuity of 7.92 million over 25 years with interest rate 8%, as if they gave you 84.54 million of today's money. You can try and develop that solution with Excel. Remember that the present value or present worth is PV, so you can use the PV function within Excel with 8% interest rate. The number of periods is 27, the annuity is 7.92, and the type is 0 because it will be paid at the end of the year. And you should get the same value or the same solution. Now let's take another example. If you graduated from college, you are 21, you started working. Maybe some of you will not look at retirement from now, so they will say, you know what, I'm gonna start paying for retirement when I'm over 30. Maybe I will start thinking of that and saving some money for retirement. Some people will say, you know what, I'm gonna save now, and then maybe when I'm 30 or above 30, then at that point I will stop making the payment. So your age at this stage is 21 years. You just graduated and you started working. After the first year, you're going to start making payments to your savings account with $2,000 a year, annuity, $2,000 a year. You found an account or a saving plan or a saving account that you can deposit $2,000 a year with certain interest, which is, in this case, we will have it as 8%. After 10 years, that means when you are at the age of 31, now your age is 31, you stopped making the payment. And from 31 all the way, after 44 periods, 44 plus 21, your age here is 65. Your age here is 65. And that's when you retire. We would like to know how much would be that future value. At the same time, we will look at the second option. The second option is deferred saving plan. I will not pay anything until year 11. When I'm 32, I will start paying $2,000 in the account, saving until I'm 65. From 32 until 65. I will see what will happen to this savings. So which option will be better for me or for you to follow after graduating and for retirement? What will be the best option for retirement? Is it option number 1 or option number 2? If you calculate the first one, you can see that your future value after 10, so you find F after 10 years, will equal to 2,000 multiplied by the factor, which is the compound amount factor that we calculated before, or you can calculate, or you can find at the back of the book, and it will be $28,973, and that will be at the end of the 10th year. Now you take this value, and this value will be the principal, and there are no other payments. So from here on, I will use that P and calculate all the way to the future. How much will be the future value for that principal? And that will be over from 10 to 44, that's 34 periods. So number of periods is 34, and the interest rate is 8%. I will use the formula for finding the future value, knowing the principal, and that's the original formula that we used before. P at this point is 28,973, 8% interest, 34 equal periods, that will equal to 396, 645, $396,000, 645. So this is the amount that I will get by the end, or at age 65, when I retire, or you retire, when if you plan to do it this way, if you plan to do it in option number 1. Now, let's see option number 2. If I go with option number 2, then I'm not making any payments from 0 to 11. From 11 to 44, that's 34 years, with interest rate 8. Then by the end of the 34 years, I will have $317,233. This will be the amount after 34 years. Which one do you think is better? The $317,233 or the $396,645? And of course, as you can see, this option is better. So usually, if you'd like, you can do early savings for the first 10 years, and you can get more than if you started after 10 years with the same amount, paying for 34 years. So option number 1 is better, but what would be the interest rate to make the two options equivalent, to make them the same? What would be the option, or the interest rate to make the two options equivalent? So I need to make option number 1 equal to option number 2. And if I do that, then I have to make the two formulas equal. So I can put the two formulas like that and make them equal, then solve for I, and we can replace the factors with the formula, the mathematical formula, and solve for I. And that will be a long calculation or mathematical algebraic method to find I. Maybe you need to do it over like 5 or 6 steps to be able to get the I value. We can do it using Excel sheet. So I can put the two options in Excel sheet, and I can put the years here, the 44 years from 0 to 44, and I can put the payments for option number 1, payments for option number 2, and then put the formula for the future value for option number 1 and for the future value for option number 2, taking into consideration the calculation that we did for both of them. And then I will find the difference between both of them. And as you can see that with interest rate 8%, there will be a difference between option number 1 and option number 2 of 79,392 and 61 cents. When I say that I need option number 1 to equal to option number 2, then I need the difference here to be 0. So my goal is to make this as 0. That means option number 1 is equal to option number 2. What would be the interest rate here that can make it 0? In Excel, there is something that is called goal seek. And in the goal seek function, it will ask you about the cell that you need to change to make your target cell equal to 0 or to certain value, and that will be the goal seek function. If you do that and put the cell to 0, then you will get the exact interest that would make the two values for option number 1 and option number 2 equal. And in this case, it's almost around 6.5% interest rate. Of course, you can see, as you can see, it has lots of digits in it, but I would say around 6.54. Around 6.54, they will be equal. The formula behind the options, we know that we are looking for the future value, so it will be the future value of F5, and F5 here is this value 10, and the 2000 multiplied by 1 plus F5 to the power 34, and for the second one it's future value where we have F2 34 and the payment is 2000. So this is over 10 years, payment of 2000. This is over 34 years, payment of 2000. And here we multiply by the taking that value to the future for 34 years. This is what we added here, is taking that value to the future for 34 years. Again, if you do that over Excel, you should be able to get the difference, or you should be able to get the interest rate that will make them equal faster than doing the mathematical calculations. Let me do that in Excel. To make it easier for us, I finished the number of years, the options, the payment before, so I opened Excel sheet and added these values here in columns A, B, and C, and now we are ready to work with the Excel sheet. So in E5, I will add interest rate, and I will put the value of the interest rate in F5, and that will be 0.08. So now I will go to find the future value of option number 1. And I will add the formula for that, and the formula should equal to and as soon as you equal to, it will pop up with the function capability. So I can put FV, and once I put FV, it will provide the argument for that, so I can start adding. And in this case it's asking me for the interest rate. That's when I add the F5 or the 0.08, and that will be my interest, comma, I'll put 10 years, and comma, I will put the payment as minus 2,000 because I'm making the payment, it's out of my pocket, multiplied by 1, and that's the P value. Now this is the new P value that will be taken all the way, so I will multiply that by 1 plus F5, the interest rate again, to the power 34 years. This value, the the future value of 10 years with a payment of 2,000, interest rate of 8%, will be taken all the way as a present value to the future of 34 years with interest rate of 8%. And that will be the future value for option number 1. So when I type that, it will be 396,064.6. And if I want to be more precise, I can add the digits or take the digits, so we can format the cell. And I will select currency with 2 digits after the decimal, and that will be the value. Now I can do the same for option number 2. So the future value for option 2 will equal to the future value, and all what I'm doing in this is just I have interest rate of 8%, so which is the F5 in this case, comma, it will be for 34 years, making a payment of $2,000 out of my pocket, and that will be it. Again, we said if you don't add the type, it will consider as if you are doing it at the end of the year, and the value will be for the type 0. So you don't need to add it all the time unless it's at the beginning of the year. Then you need to add 1 after the 2,000 here. But in this case, since it's 0, we just have it, and we will have $317,253.34. And if we specify the target cell will be this value minus this value, and that will be $79,392.61, and that will be the target value. Now, how can we use the goal seek function? We click on the data tab up here. We click on the data tab, and you will find the what if analysis here. You click the arrow and you get the goal seek. If you click on the goal seek, it will tell you which cell would you like to set. So this will be my target cell, which is now $79,392.61, and I would like to set it to be a value of 0. That means I would like the difference to be 0. By changing a cell, which cell would you like to change? Then I can press on this one, and select this, and that will be the cell that will change. Okay, now once I'm done, I just say okay, and it will continue seeking for the difference until it reaches to a goal of 0, which is 0 difference between the two values of option number 1 and option number 2, and that will be when the interest rate is equal to 6.538%. 6.538%. So that will be the interest rate for the two options to be equal. So you can try that yourself. Just do that for two options, and you can, like I said before, you can create your own different Excel sheets to calculate the future value, the present value, the annuity for the different questions or the different problems that you might see in the book, or even later on in life. You can set up your own goal or your own options for retirements, for payments, for annuity, for even selecting the proper investment method that you would like to select. So going back to our slides, we can see that with 8% interest, we would prefer to do early savings and get 80,000 more than do deferred savings and get 80,000 less. If we would like these two options, or if I see that the interest rate is 6.538, then both of these options will be the same. Then I will not select, it will be the same if I select any of these options. It will not make a difference for me. If it's more than 6.5%, if it's 7, 8, whatever, then I will select option number 1. If it's less, then I have to recalculate, and most likely I will go with option number 2, because less than 6.5%, most likely option number 2 will be better. At 6.5, both of them will be the same. Above 6.538, then option number 1 will be better than option number 2. That will be all for this session. If you have any questions, you can email it to me. Thank you and have a great day.